So before we get to the problem of ranking web search results, I want to talk about one more interesting recursive definition, the Fibonacci series. And Fibonacci numbers are one of the most interesting things in mathematics. Once you know about them, you'll see them all over the place, both in nature and in human designs. The name comes from Leonardo da Pisa, who is also known as Fibonacci. And back in 1202, he published a book called Liber Abaci. The root abaci is the same as the one for abacus, the calculating machine. And this translates loosely as Book of Calculation. This was the book that introduced Indian mathematics to the West. In particular, it introduced what we now know as Arabic numerals. This replaced the Roman numeral system that was then widely used. And part of what Fibonacci did in the book was show how much easier it is to do calculations using numbers in the decimal system, where the place where the number is indicates its value. And as part of the book, he introduced these problems and showed how to solve them using calculation. The problem that became known as the Fibonacci numbers was one of the problems in the book. And he posed the problem like this. So at the beginning, we have one pair of rabbits, and it takes 1 month for a rabbit to produce offspring. And every month, a mature rabbit will produce a new pair of rabbits. So at month 1, we had one pair of rabbits. At month 2, well, we have the one pair we started with, and now we have a new pair. We have 2 pairs of rabbits. And now at month 3, the baby rabbits aren't yet ready to produce offspring. It takes a month for the rabbits to reach maturity, but these 2 will produce new offspring each month. So we have one new pair of baby rabbits, and the rabbits that were born in month 2, well, they've had a month to get bigger. So now they're mature rabbits. So we had 3 pairs at the end of month 3. So month 4, we still have the 3 pairs of rabbits we had. Rabbits never die in this model. And the 2 pairs that are mature, both of those will now produce new rabbits. So we have 2 new pairs of baby rabbits. The baby rabbits that were born in month 3, well, now those are mature. So now we have 3 pairs of mature rabbits and 2 pairs of baby rabbits. So we have 5 pairs of rabbits total. And this keeps going. So the model assumed that rabbits never die, that every month each pair of mature rabbits produces a new pair of rabbit babies, and it takes 1 month for a pair of rabbits that's born to become mature. So in month 5, the 3 mature pairs of rabbits will all produce new offspring. So we have new offspring, 3 new offspring, and the 2 that are a month old that were born in month 4 will now become mature. So this isn't a very accurate model of how rabbits reproduce. It's good for us. If it was an accurate model, it would only take a few years for rabbits to control the entire planet. But it's an interesting mathematical model. And the model that this poses, we can write in a more formal way. So each month, the number of rabbits is the number of rabbits we had in the previous month, since those rabbits don't die. So in month 5, we had the 5 pairs that we had in the previous month, plus all of the rabbits that were mature, meaning all the rabbits that we had 2 months ago, which was 3 if we're in month 5, well, those reproduce. So we have 3 new pairs of rabbits plus the 5 that we had in the previous month. And this keeps going. So we could, in month 6, we're going to have the 8 rabbits that we had at the end of month 5, plus the 5 mature pairs, 1, 2, 3, 4, 5, will each reproduce. So we'll have 5 new pairs, and that will give us 13 pairs of rabbits. So this was the model Fibonacci developed. And the question is, can you figure out at the end of month n, given any number n, how many rabbits there will be? So the way we define this mathematically is a little different from the way Fibonacci posed the question. And that's because in modern mathematics, we usually like our series to start with a 0. If we're thinking of modeling rabbits, well, that doesn't quite make sense to start with 0 rabbits. But if we're thinking of it as more general series, it does. So the way it's defined mathematically is that we say that the Fibonacci number 0 is defined as 0. Fibonacci number 1 is defined as 1. And those are our 2 base cases. So this is different from the other recursive definitions we've seen in that there are 2 base cases. Previously, all of our definitions just had 1 base case. And then we can define every other Fibonacci number recursively starting from these base cases. And so the Fibonacci number n, where n is some whole number greater than 1, is, well, we have all the rabbits in the previous month, so that's Fibonacci of n minus 1, plus all the new babies. And the number of new babies is the number of rabbits we had 2 months ago. Those are all the mature rabbits. That gets added to the number of rabbits we had the previous month. So that's how we define Fibonacci numbers. This defines every Fibonacci number in terms of the 2 base cases and the 1 recursive case. So your goal is to define a procedure called Fibonacci that takes a natural number as input, so numbers starting from 0, any whole number, 0 or higher, and outputs the value of that Fibonacci number, defined using this recursive definition.